Now, this illustration deals with other loads. Now, when we talk about other loads in this illustration in accordance with 210.20a, we're speaking about the overcurrent device ahead of the conductors and the equipment that the conductors supply. Now, notice in the illustration we have a 6 amp non-continuous load and we have 11 amp continuous load. And 210.20a deals with the overcurrent device in the panel board. 210.18 would deal with the branch circuit being identified with its maximum rating by the overcurrent device and not the size of the conductors. Now, what this section is trying to get over to the electrician or anyone dealing with this circuit is that it's the rating of the overcurrent device in the panel board that determines the rating of the branch circuit. So, for example, we might have a number 10 conductor for voltage drop connected to a 20 amp circuit breaker, so it's a 20 amp circuit. The number 10 wire is not taken into consideration under these conditions of voltage drop. So the question is what size overcurrent device and THHN copper conductors are required based upon the ambient temperatures of 155 degrees Fahrenheit. Now, usually to get into that heat, you're either on the roof or you're right up against the ceiling in the valley of the roof, where you see in times past electricians run those conductors, and then they would have heating problems back at their circuit breaker and the service equipment. The insulation would be baked out. The terminals of the breaker would be gray, charcoal, or begin to turn black. The insulation would be brittle. The insulation would be trying to separate from the copper or the aluminum. And notice 70B warns you of this in 15.1.3, which lists about 3 other sections to review from the Annex L to 70B that tells you, watch out for this. See if you have heating problems. So you either have to reroute it or you got to allow for that, for this temperature. So step 1, we do the calculations in accordance with 210.19A1 and 210.20A, conductor sizing and overcurrent. So to the left of the step 1, we're sizing conductors. 125% 11 equals 13.75. 100% of 6 amps is 6 amps, and we total 19.75. Connected load is 17 amps. Calculated load is 19.75. And from this calculation, conductors to the left, overcurrent device to the right, telling you what, when I multiply by 125%, I derate the loading of the overcurrent device 80%, so the conductor comes along at 125%, and sizing the overcurrent device to terminate to the overcurrent device for any load that operates for 3 hours or more is identified as continuous load in Article 100. Step 2, we're going to apply then our table 310.15C1, and we basically take number 12 wire at 30 amps times 58%, because of the derating for our correction factors, routing in through more basically in 10% or 10 foot at 155 degrees Fahrenheit above the 86 degrees Fahrenheit permitted from table 310.16. So step 2, we are looking at our table 310.15B1 because it's correction factors. If it was adjustment factors, as I previously mentioned, we would look at our table 310.15C1. Now, step 3, we're applying our table 310.16, 240.4B, and table 240.6A. Now, 17.4 amps is a 17 amp load, connected load, but the calculated load in step 1 is 19.75. So that would require a 20 amp overcurrent device when you rounded it up, and number 12 wire, which would be selected from 240.4, D as in dog. So the solution and answer is number 12 THHN copper conductors. A 20 amp overcurrent device would be required for that branch circuit based upon its conditions of use. And that's what our figure 14-20 is illustrating. Billy,